Thanks, guys. I appreciate you inviting me to come out and speak virtually as much as we can here. So I'm telling you about who I am. I'm Blaze Stewart. I am a Microsoft Azure MVP. I focus a lot on Azure. That's what I do for a job as well. I spend a lot of time doing a lot of what I might call Azure evangelism, if you want to call it that, because I spend a lot of time doing things like meetups as well as producing content for the web. So I have quite a few videos. I'll share at the end of the video or into the webinar here to more content that I have out there. That if you want to go deeper into Kubernetes, I have like a whole suite of videos out there, about 30 videos that you can go out there, watch at your leisure, and just kind of goes deep into various topics on Azure Kubernetes Services in particular. But today I'm going to be kind of hitting the high stuff, the high points of it. So that's really what I'm here for. It's a crash course in Azure Kubernetes Services, but just as if you've ever dealt with Azure, if you've ever dealt with Kubernetes before, you know it's a mile wide and a mile deep. It's a very robust piece of software that has a lot of different features. So it's not something that you're going to be able to really get your head around in an hour, but at least you can get a good start. And that's really what I'm going to try to do tonight, to kind of give you the fundamentals of it and work in that. So a little bit about who I work for. I work for a company called Wintellect, and we are a consulting and training company. So we do a lot of work in Azure. I'm not going to spend a lot of time talking about Wintellect, but we do consulting work in the Azure space. So we kind of help companies come alongside them and then help them put their workloads in Azure, as well as do a lot of custom app dev. A lot of times it's targeted for Azure, so website development, mobile app development, and we also do a lot of risk assessments and that kind of thing. We also do quite a bit of instructor-led training. So we have been Microsoft's number one training vendor for many years now, and we've trained thousands and thousands of Microsoft employees. So we are very embedded in the Microsoft space. You can see that we've got awards, partnerships, gold on a lot of things. We pretty much live and breathe Microsoft stuff. So that's kind of what I do as well. So I work for a company that's got a tight relationship with Microsoft therefore I have numerous certifications in Microsoft tech. I've got, I don't know, I think I'm up to like 15 certs in Azure now, old and new ones. I mean, I've been doing it a while. But in any case, enough about me and my company. Let's get right into Kubernetes. So what is Azure Kubernetes Services? Fundamentally, Azure Kubernetes Services is Kubernetes on Azure. So Azure Kubernetes Services is Microsoft wanted to take the previous attempt at containers and bring it up a level. So what to kind of give you a backstory on what happened when containers first came out, they kind of hit the IT scene around 2015. It's kind of a fledgling technology, and as you know, with a lot of fledgling technologies, there's a lot of churn. So there's really no clear leader of what's gonna happen. So Docker came out with Docker containers, and that kind of reinvented the container industry, the container subsection of the IT industry, and there was this fury of activity around how do we make this idea of container scale, and you end up with this idea of a container orchestrator. So out of that grew several attempts at it. Mesos was one of them. Docker Swarm was another one. Kubernetes was another one. There was a couple other ones I don't care to mention, but those are probably the three most common ones. And of those three, the one that kind of rose to the top was Kubernetes. And for better or worse, Kubernetes has since that time become, so it's about 2017 when it really became more or less the king of container orchestration. Became more or less the de facto standard now. I mean, there's still a few folks using Docker Swarm, but if you talk about container orchestration nowadays, 90% of the time, 95% of the time, folks are going to be talking about Kubernetes, because it is really, given what it can do and the platform that it gives you, it's very robust. So fundamentally, there's a lot of features that Azure brings that are value add to Kubernetes, though, because Kubernetes on Azure is fundamentally a service. So prior to Kubernetes really becoming a service, it was really more or less infrastructure. So you think about infrastructure, you think about virtual machines, you think about having to maintain networks and configure all that stuff. And the early attempts at Kubernetes required that you build VM clusters. You had to manually build the networking. You had to manually design all this stuff to get your clusters up and running. And then the idea of doing this as a service became more popular. And so what the cloud providers started doing is trying to figure out how they can take this the difficulty of trying to build all this infrastructure and offer it as a service rather than you having to build this all manual yourself, maintain it yourself, and patch it, upgrade it, do all that. And so Microsoft came out with version 2 of their Kubernetes offering, and it was called Azure Kubernetes Services. And that was about 2 years ago, 2.5 years ago, when they came out with it. And it really kind of got away from you having to do a lot of manual intervention into the service and instead really let Microsoft manage the infrastructure for you, and you really focus in on making things work on Kubernetes. So it took a lot of that headache away from you. And there's also some other value adds to it. Like in Kubernetes services on Azure, you only pay for the nodes in which your Azure resources are running on. Now I'm going to get to the architecture in a minute, but this is important because if you were to run this on like GCP or you're running an AWS, as part of your cluster, you have to have these things called master nodes, which are responsible for the maintenance of the worker nodes, which are underneath it, that are actually running your workloads on Kubernetes. On Azure, you only have to pay for the nodes that are running your actual containers, and that's a value add that they bring to the table. So you're only paying for really the pieces that are running your applications. It's also, I would say, fully managed. This might I've gotten pushback on when I claim it's fully managed. You don't have to manage the cluster. It is a fully managed infrastructure in that you really don't have to touch the infrastructure if you don't want to, but there's this kind of shared responsibility because it does expose the infrastructure. And when I set this up, I'm going to show you where it exposes it. But the exposed infrastructure is managed through the APIs that Microsoft has integrated with it. So it's something that you don't really have to think about. You just spin it up. It's there. You can see it. If you want to mess with it, you can. But generally speaking, you don't have to. And so you just focus on making Kubernetes work for your application, and Microsoft will take care of the infrastructure for you. It's easily scalable. Literally in the portal, you can come in and you can just drag a slider and you can add new nodes into your Kubernetes cluster, and that will automatically scale that if you want to do that as well. So it's very easy to scale it without having to add a whole lot of capacity or manually create VMs or do any of that. It will just automatically add new compute to your existing clusters. It fully integrates with other Azure services like Azure Application Gateway and load balancers. It integrates with things like Azure File Storage, Azure Blob Storage. It'll integrate with your VNets. It does a lot of cool things in Azure that are first-party services that are just work inside of Azure Kubernetes Services. So you don't have to do a lot of extra configuration to use a lot of these kinds of things in Kubernetes with Azure. It even integrates with a fairly recent development is it integrates with Azure AD for RBAC roles on Kubernetes. I'm not going to get into the security a lot with Azure Kubernetes Services, but that is a rather recent development. So they're adding more and more features to this so that you can take advantage of all the other great Azure offerings while you're using Kubernetes as well. So if you wanted to use like a Key Vault to store your secrets, you can store your secrets in Key Vault and put those into your Azure and into your Kubernetes cluster, and they be stored securely but be exposed inside of your applications running on Kubernetes. So it does have a lot of cool things related to Azure. Another cool thing though is that it also is a very fully supported Kubernetes environment. So it's not like it's a half-baked attempt at Kubernetes. It is a standards compliant Kubernetes implementation. So there's not like if you can make something run on Kubernetes on Amazon, making it run on Azure is going to be very easy, and vice versa. If you can put something on Kubernetes on Azure, you can easily take it over to Amazon or GCP or do it on premise. So these are some of the cool things. So it kind of marries the best of both worlds, where you have this managed platform, but it's also more cloud agnostic than what you would have if you were running it on a managed platform as a service or something that was more specific to a specific cloud provider. It gives you a lot of those kinds of features so that you can have the full open source experience, but still not have to worry about a lot of the configuration nightmares and all the other things that go into making Kubernetes happen. I want to mention Azure Container Registry tonight too. I'm not going to really get into it, but it's another service that you can integrate with it because it brings to the table the ability to have your Kubernetes environment integrate with Azure Kubernetes Services so that you can have a private container registry for your Docker images so that you can put these into Azure Kubernetes Registry, have it secured on Azure, encrypted with your keys, and then it integrate with your Kubernetes services on a private network of sorts so that you don't really have to expose your container registry or use a public one. And it's very easy to set this up right when you create your container cluster on Azure using the portal, or you can do it through any of the automation tools that are available to Azure as well. And there's a lot of cool things you can do that. So we've talked about Kubernetes. It's an orchestration engine at scale. And we've talked about Azure Kubernetes Services. And fundamentally, Kubernetes at its core is an open source project that is fully owned by the Cloud Native Foundation. It's a orchestration engine, as I mentioned, for running containers specifically. Kubernetes was not originally intended to be for containers only. It was actually intended to be more of a general purpose infrastructure technology. And it was designed to be able to run, yes, Kubernetes, Docker containers, but you can also run other kind of containers with it. So you can run Rocket containers if you wanted to use those. And there's various ways to run applications that aren't Docker containers. The lion's share of everything that you run on Kubernetes, though, or probably the 99% of everything you're going to be running on Kubernetes is probably going to be a Docker container. There are a few niche cases where that's not true, but it's like if you're talking about running on Kubernetes, 99% of the time you're going to be running something in a Docker container that's going to be plugged into a Kubernetes environment. So that's the lion's share. Of course, you have those edge cases though as well. And being that it's open source, Microsoft doesn't own this. Google doesn't own this. Amazon doesn't own this. They are all kind of contributing to it, and they're all competing with one another to provide the service as well. So that's actually better for the user ultimately, because now you have a lot of the big players that are adopting this platform, but they're all making valuable contributions to it, and then they're out trying to outdo one another, so it ultimately drives the cost down, and you get all the advantages of all the competition that brings as well, but you also get the advantages of all the innovations everybody brings to the table at the same time. So it's kind of captures the essence of open source, but also the advantages of the competition that brings as well. So let's get into the actual technical details about what Kubernetes is. Kind of we have a context for it. The first thing that we have to understand with Kubernetes is the concept of a pod. Now, a pod in Kubernetes is the most fundamental option or fundamental building block of Kubernetes. So this is what you're going to deploy your containers into. So you have a container inside of a pod. A container is your application's host. It's what contains your application. So you're going to build a Docker image. You're going to take that Docker image, push it to a registry, and then when you go to deploy this to a platform on Kubernetes, you're going to actually put another wrapper around that, and that's the Kubernetes wrapper, which is called a pod. So a pod can actually have multiple containers in it. That's generally not a good practice to do unless that you have a primary container and you have what they call a sidecar container, and the sidecar container is typically going to be doing some kind of support service for the primary container, but you wouldn't want to cram all your application's components into a single pod. Rather, you want to break it up into multiple pods, and if you need to put that so-called sidecar container into the pod, you can do that, and there are some legitimate use cases for that, such as when you're running a service mesh, which is kind of outside of what I'm talking about tonight, but that's one case where that becomes legitimate. And the pod really defines the resources that your application has, like CPU, RAM, and networking and storage. And so you have the name of the pod, you will have the labels that you can attach to that. That's used for something called Kubernetes selectors, which you use for getting a reference to your pod or filtering on that in Kubernetes. And we'll look at some of this later on when we talk about some deployments inside of Kubernetes. It defines the storage. And so the storage for a given pod is shared among the containers and things like that. So just the basic takeaway here is to understand that the pod is the most fundamental building block. And then you take the pod and you build on top of that, and that is really where the rest of the talk is going to kind of go from here, is this idea of, now that I have a pod, what can I do with this? How can I build an application, deploy an application, scale an application using this fundamental building block here? So that's where the idea of a controller comes in. A controller is a thing on Kubernetes that manages pods. So a pod is the most fundamental building block, and you want to give some kind of behavior to that pod. So in that controller is what controls that behavior. So a pod is just a generic building block. So I put my container out there, big deal. But what if I want to create a set of pods that dynamically scale whenever my CPU threshold goes up to 50%? I want to add more compute or more instances of my application. That's what controllers are for. So they're going to be actually maintaining the health of the pod, and you can do things like load balancing across pods with controllers. You can do things like scaling, as I already mentioned, across your pods with controllers. You can do things like guaranteeing that one pod comes up on every node in your Kubernetes cluster with controllers. These control things like scheduled jobs. If you want to run that in a pod, a controller would be useful for those kinds of things. The networking on Kubernetes is all managed through controllers. So all of the behavior of a Kubernetes cluster is fundamentally going to be a controller of some kind. The pod is what is going to be managed by the controller. So these two things working in tandem are really going to shape what shape the behavior of everything on your Kubernetes cluster. So there are several different types of controllers that are specifically for application deployments. Now, this is not an exhaustive list. These are primarily the ones that you use for the actual implementation of your application. So a lot of these some of these are deprecated. When I might say deprecated, they're not as used often as they once were. So if I was to, I highlight those. Okay, these two are the two most common, I think, that I've experienced. Deployments and stateful sets. The first two, replication sets and replication controllers, are less common nowadays, but deployments, these are very common nowadays because they have rollback options, and these gives you the ability to deploy something. If you need to go back, you can do a rollback on that to roll back to a previous version if you borked the rollout of a particular application, and it gives you the ability to do rolling updates and things like that across your deployments whenever you go to put things on your cluster. I haven't used a replica set in probably 2 years, or a replication controller in 2 years, in over 2 years. I've used deployments heavily. I've used stateful sets sometimes. I've used daemon sets less often, but the deployments and stateful sets are probably the two most common. Jobs and cron jobs are useful for like batch workloads, and those are the two that you're going to use for those things that you want to run on a schedule, or you want to run it, and then finish, and then shut down whatever that compute is. But for primarily for applications that are mostly like databases, websites, any kind of service like Redis, or something along those lines, like a messaging platform, anything along those lines, deployments are probably going to be what you would use, or sometimes stateful sets if you need to maintain some kind of uniqueness among the pods that are deployed inside of your different kinds of applications. Now, stateful sets are used for things like databases more, but deployments are typically used for things like websites or microservices, or those kinds of things that you might have running. So those are the types of controllers. We're going to look at some examples of this when we go to a demo. And I do want to kind of do an overview of the architecture of Kubernetes, because this is the kind of the understanding this is kind of fundamental to understanding how a cluster works and why it works the way it does. And so you have the master nodes that I've talked about. Those are free on Azure. You don't have to pay for those. Those are responsible for managing your cluster. And then you have the compute nodes, which are the worker nodes that are going to be responsible for running your applications. And that's where your pods for your application actually get deployed. And the next thing that you need to have is the API server. So whenever you go to run commands against Kubernetes cluster, you're going to be using a client that interacts with the API server, and it's going to command a controller manager. So all your controllers integrate with that API server, and then they work with the controller manager and the scheduler for brokering the actual workloads down on the actual the worker nodes. So understanding that the scheduler is the actual thing that commands the actual pods on the actual nodes. It's a very important component, because the controller manager is the thing that, okay, here's what the controller is doing. I need I need 6 pods created. And then the controller manager goes and tells the scheduler, go create me 6 pods. The scheduler then goes out there and looks at the cluster and say, I've got some room here and some room over there. Go create me those pods on the various nodes on the cluster. etc.d is a key value store. This is how Kubernetes maintains its configuration data, and there's also some logging data that gets put in there and some other things. It's an important component that you can query against to get data about your cluster as well. The nodes down here, the actual compute nodes, have a couple of components that are important. The kubelet is the agent that interacts with the controller, the scheduler, and it's what receives the commands from your scheduler, and it's what's going to it's what's going to create all the pods on that particular node. It also has C Advisor that's responsible for monitoring the nodes. It reports back telemetry back up to the scheduler to say, hey, we're getting low on RAM, we're getting low on CPU. I need some more resources, or move this pod over here off this node because I'm just out of resources. I'm overtaxed. And then kubeproxy provides a lot of the actual networking that goes along with your components here. And then, of course, you have the pods themselves that we've mentioned already, and that's where your application runs. And then lastly, you have the network plugin. That's what interacts with the actual underlying operating system that will broker the connection to the actual physical network or the actual virtual network if it's a cloud provider that's going to be working with your particular cluster. And it's what's going to create the overlay between your various nodes, so it acts like a more seamless network across all of your clusters so that things flow very nicely and that you don't end up with a lot of disparity between your various cluster nodes. So I know that's a lot to take in, but the main thing to recognize here, if I had to say that there was an important thing to recognize here, it's mostly to understand the relationship between the API server, the scheduler, and the kubelet, because these are the 3 main components that you're going to be hearing a lot about when you talk about Kubernetes. The scheduler, again, is that thing that says, go create me 6 pods. The kubelet's the actual thing that does that. It's what's going to pull the images and then spin up those pods with the containers in them. And then understand that kubeproxy is what's going to be end up doing a lot of the exposure for your users inside of your application there. But those are the major components. The rest of this isn't as important, especially in Kubernetes services, because a lot of this is abstracted away. You really never have to manage it. You don't have to set it up. If you're building a node, if you're building your own cluster manually, that becomes very important, especially the networking plugins. But in Azure, that's all kind of taken care of for you, so you really don't have to deal with that. So with that in mind, let's go into the portal and just walk through creating a Kubernetes cluster, and so that you can get a good exposure to this. Let me get an instance of Google Chrome here, and let's go to the portal. And I'm just going to walk through a cluster creation process here to talk about this. And then that way you can kind of see the options that you have available inside of this. So I'm going to come over here. I've got this resource group called Temp Kates here, or Temp Kates is short for Kubernetes. That's taking Kubernetes is 10 letters. So if you take the middle 8 letters and you drop them, you just put an 8 in there and you get Kates. And so if you hear somebody call it Kates, that they're talking about Kubernetes, but they're really just phonetically reading that right there. And I'm going to go add a resource here. And I'm going to come down here inside of Azure. I'm going to go to Kubernetes Services right here. Of course, you have a lot of other things. DCOS, which is Mesos, it still exists, and you can still spin that up. But we're mostly looking at Kubernetes Services tonight. And I'm going to give my cluster a name, and I'll call it Blaze demo here. And I'm not actually going to create this. When you're going in through the portal, here's what you can do. There's a lot of things you can configure here. You can put it into a lot of different regions. Of course, these are the supported regions for Kubernetes. So if you want to put in South Central, East US, West US, and there's several around the world as well, if you want to get more regionally specific. It also supports a lot of different versions of Kubernetes. Now, with each new version of Kubernetes, they're adding new features or fixing old features or adding new functionality. So you kind of have to be careful whenever you choose your version level that it will support with whatever you're using in Kubernetes. I've run into some cases where I was trying to deploy something and it just wouldn't work. And I was like, what's going on? I went and looked at the docs. Oh, I'm running an old version of what I'm trying to use, or I'm running an old version of Kubernetes, or maybe the version's too new or whatever, and it just breaks. So you got to kind of be careful about what version you choose. It's going to default to one, and they're always adding new ones. So you can always upgrade, but you can't go back. So that's important to remember. So I generally will shoot low, and if I need to, I can go forward, but going back is not possible. So just something to consider when you're creating a cluster. Here's where you can change the node count. Of course, you can drag it up to 100 nodes, and then you can also change the VM size on Azure. So you can support up to single core VMs with a little bit of RAM, or you can get some of these larger VMs. If I was to remove all of these filters here, if I was to remove all these features here, if I wanted to get some insane amount of core count here, I can add nodes with that. I would have to remove some features here. I'm not sure why they're not showing up. Maybe I've got something here, but whatever. You can add up some larger VMs, like again, 8 cores, 32 would be a fairly large node for a Kubernetes cluster. Typically, most of your cluster nodes, you don't want to get them too small, but you don't want to get them too big either, because you end up with a lot of waste. I typically on Azure use either the DS3. Use the DS3 V2s or DS4 D4S V3s right here. Those seem to be a pretty good balance of RAM and CPU. 4 core 16 gigs or 4 cores and 14 gigs and things like that. And then for demos, I typically use these down here or whatever. But in any case, there's a lot of options and you can get those. Those are available. Next thing that you can do here is sort of configure node pools. There's something cool about the ability here is with Kubernetes on Azure, you can use Windows containers as well as Linux containers in a mixed mode environment. So you can use you need at least a cluster pool, a node pool, and that's a set of nodes that is dedicated for running Linux containers. You need to at least have one of those on Kubernetes. However, with Kubernetes, you can also add different kinds of compute into what they call node pools. A node pool is basically a set of VMs, and they're all identical. So if you want some node pools for running larger applications, you can do that. So you can create a small one that has small nodes and one that has large nodes. You can create one for Linux containers and one for Windows containers. And you can have those coexist side by side, and they will talk to one another. They integrate with one another. But you at least have to have one node pool that has Linux containers on this for it to work. But I'm not going to go through creating that. But you get a default one with Linux running on it. Now, this idea of virtual nodes is kind of cool too. This actually uses something called Azure Container Instances, and it gives you the ability to have on-demand compute. So typically with a Kubernetes cluster, you have dedicated resources that are virtual machines where you have reserve the RAM, the disk, and the CPU for as long as you have that node up. If you want to, on Azure Kubernetes Services though, you can have on-demand compute that will run for a period of time, and it's billed to the second. So you run it for 50 seconds, you only get billed for 50 seconds. In an agent pool right here, what you're going to be billed for is you're going to be billed for the node, whether you're utilizing it or not. With this, you're only getting billed for the time amount that you use it. And that's a kind of a cool feature. So it enables you to have dynamic compute, and it will install on your Kubernetes cluster what they call a virtual kubelet. Remember that component we talked about? That kubelet that does the creation of pods. Well, that's going to create instances of Azure Container Instances that will have a container running them in a pod that will spin up, run for a duration of time, then shut down. And then at the end of that time, it'll shut down and you only be billed for 5 minutes or however long it runs for. And this is really good for batch type workloads or jobs types workloads. So on the next tab, this is where you can integrate, you can turn on RBAC here. And you can do system assigned identities. This one, I typically encourage people to use managed identities now rather than service principals. If you're creating a new cluster and you're not sure, go with managed identities. If you have a service principal, you know what you're doing there, use a service principal. Managed identities gives you the ability to manage the identity with the cluster, and it will delete the identity when you delete the cluster and that kind of thing. And so this is a better option for most people. However, if you know what you're doing and you want to use service principals, you can do that. I typically just go with this one because it's simpler. RBAC is something, if you want to enable RBAC on the cluster, that's for security on the cluster level. You can integrate AD. It's not available in the portal yet, but it is GA'd. So you can turn this on and then integrate AD with it. And then that'll allow you to use AD logons with your Kubernetes so that your developers can get an account, log on to Kubernetes, and then they can actually create this. And then the networking here, you have basic configuration. I typically go with advanced, and this gives you the ability to plug this into an existing VNet if you want to use it. But this gives you the ability to fine tune the address space available to your Kubernetes cluster. You can do something called private clusters here. What this will allow you to do is make sure that the API endpoints are on a private network, so they're not publicly accessible. And for some people that have strict security requirements, having a private cluster means that you can only access the APIs. That is the master node APIs, that API server that I was talking about, over a private endpoint. And so that gets exposed as a private endpoint on your VNet, and therefore you can't just access it through any random connection on the internet. So that's a good security feature here. A network policy is another feature that is available. It allows you to segment your container up using these things called network policies. I'm not going to get into that tonight. Application routing is something we're going to talk about when we talk about ingress. You can turn this on, but it's generally not encouraged to turn this on. This installs a default, what they call a default ingress controller. And I'm going to talk about that later on, but just you can turn it on for dev test, but disable it for production clusters. You can integrate it with Container Registry. I mentioned that already, and you can turn on container monitoring with Azure Monitor. You can monitor your containers here, and you can do a querying against that. You can get your logs out of your containers here and turn that on, and you can have a dashboard that will show you your container's health. You can see the activity inside your container using this log analytics workspace. And so once you have that all configured, you can tag it and then create the cluster. I'm not going to create this one. I'm going to go to the one I already have created. And once it's created, you'll end up with something that looks like this. And this is what Kubernetes looks like once it's created. And so you can come back and you can configure a lot of the various components that we did look at here, where you can have you can configure node pools, you can add new pools, scale them up, scale them down here. You can turn on automatic scaling here. As well, you can scale up the number of nodes. You can scale them down. You can change the network configuration by enable HTTP application routing here, or you can disable that there. Remember, just generally leave that disable for production, but enable it for dev test. Dev space is a kind of a cool space feature that gives you the ability to create segments of your cluster for developers to use. I'm not going to get into that. It's got integration with GitHub. So you can use GitHub Actions to deploy your containers from GitHub. You can integrate it with Azure DevOps and a lot of other external tools as well. And then you got all the monitoring options as well, and on and on and on. So it's got very deep. The whole reason I wanted to show you this is so that you can see the level of integration that this has with Azure. Azure is it's a first class product on Azure. It's not a third class product. It's a first class product on Azure. So it integrates with almost everything that Azure can throw at it. So therefore you get a very rich experience, not just with Kubernetes. You can take advantage of the entire Azure ecosystem by using Kubernetes to run your applications as well. So that's the cluster. Let's go in and look at some of the kind of cool things that you can do with this now. That's not the right deck. That's one from after this afternoon, my other webinar. Let's talk about container workflow real briefly. So whenever I'm going to skip past this slide, we don't really talk about this one. I'm going to talk about we talked about common types of controllers already. Let's talk about services now. This is a cool concept inside of Kubernetes. Now that we've talked about the idea of Kubernetes, the architecture of it, and kind of what that looks like in the context of Azure, let's look at getting something running on Kubernetes. And the first thing that you want to do is create a service that exposes a set of pods. And so what that does, the way that works is using what they call a replica set or a deployment. So the controller here is really not the issue. This is a little bit dated from when I first built this deck, when replica sets were used more. But you would use deployments or daemon sets or stateful sets more nowadays. It doesn't really matter. It'll all work with a service. Basically what that does is it creates a cluster of pods, if you will, on your Kubernetes cluster, a set of pods that are managed by a controller. Remember that controller thing I talked about. And then what this will do is it integrates with the kube proxy, and it will expose a port on that kube proxy. And so what that's going to give you is an IP that will be exposed either privately or publicly by way of that kube proxy component to the public internet or to your private network or to the cluster, depending on how you set it up. And what that gives you is the ability to reach that from the network through the service and into your pods. And this is going to act like a load balancer as well. So the kube service, the service that you define here, is going to expose your applications over a network. It's going to do some load balancing across those, and it's going to give you a lot of ability to integrate this with TCP type services. So services are fundamentally TCP connections into your pods. So this would be for things like SSH, or for, you can use it for HTTP, but that's what we're going to talk about in a little bit, called ingress. You can use it for database connections, such as a MySQL database. You could put that on port 1337, and you would expose that as a service if you wanted to have a database cluster running inside of a set of pods as well. So this would be useful for TCP and UDP type connections. So this is what you're going to expose whenever you get your applications TCP based, and you can also use it for HTTP applications as well. So there's a couple kinds of services that you can expose. Remember, like I said, that you can expose these publicly on the cluster itself or privately. And so if you expose something, a type of service called a load balancer, this is actually a kind of a misnomer, but it's basically an external network. It's going to expose your service externally. A cluster IP is going to expose your service to an IP on the network, on the internal network that your cluster is attached to. So this would be for public facing workloads, so like public IPs. This would be for like private IPs that are on your network. And then the last one is a node port. And what this is going to do is it's going to expose a node port on one of the cluster's IPs. So this is like internal to your cluster right here. This is more external to your cluster, and this is exposing a single node on your cluster rather than through a load balancer. This would expose your service using one of the IPs of your node. This one is not you. This one's good for dev test workloads. I don't really use it for much anything other than that. These are common for more production-oriented workloads because, again, external networks here, internal networks here to the cluster. And so this would be exposing a service, a load balance service, to other things running in your cluster so that they can access that resource through a load balance configuration. This one is for external services, so like in-user applications like browsers connecting to your service. So let's go and look at one of these services and get these up to Azure and running on my Kubernetes cluster that I already have. I'm not going to build the Docker file because we're getting a little short on time here. I'm just going to go ahead and deploy this. I know this says end-to-end demo, but I can just go and deploy something. Don't need to do that. So let's go and look at my manifest file here. Now, Kubernetes uses these things called manifest files to define resources. And a manifest file is, in Kubernetes speak, is basically the configuration for it. And so here inside of my text, let me pull my text editor over here so you can see it. Inside of my text editor here, we have a service that I have defined. And this is how I actually define a Kubernetes resource through the declaration of something called a service. So remember that service I just talked about. And notice what I have here is I have some metadata about this defined. I'm defining the ports that I want to. This is just named HTTP. I'm not saying anything about the protocol here. It's just its name. I am exposing port 80 here. And notice the type here. I'm telling it I want a load balancer as my type of service. So remember, that's my external load balancer here. Down here is my deployment. So this is my controller type. So this is that controller thing I was talking about. And basically what I'm doing here is I'm saying I want a deployment with a single node. I'm going to show you a deployment later that's got more than one replica to it. But this particular one has a single replica, and here's my container spec of everything that I'm going to be running inside of this particular deployment. So it's basically going to create one copy of this container that's going to be running inside of my pod, and it's going to expose that on port 80, and that's how it's going to run. Now, the way that I link this up here is I use these things called selectors. A selector will select my application based on my app's name down here. So if I come down here and I say match label app, my selector right here is called I have my app labels called Keen right here. That's my template. I have a label here that's matching up that, as well as this one up here for my selector. And so what that does is it kind of brings all of those together. Whenever this goes to look for what am I exposing, it's going to be using these selectors to link the actual service to my actual deployment down here. I'm not defining any IPs by doing that. So I'm just using the selector syntax available inside of Kubernetes. And then Kubernetes is going to create the linkage, the actual physical linkage at the network layer that's going to bring all this together. It's going to create the IPs. It's going to know how to route the traffic. And that's all based on the fact that I'm using the selector to tell this service to expose this deployment down here. So let's deploy this. Let me get a reference to this. I think I already have one. No, I don't. Let me launch my shell here, and let me get into this particular folder here. I can go like this, and I can come over here, get the directory. Let's pull this back up and do a CD here, CD that, and I can then do, let's make sure I'm on my cluster. I think I am, since this is the last one I connected to. Now, there's a command line utility called kubectl, or kubectl, or kubecontrol, depending on who you ask. That's how you're going to interact with that API server I mentioned. So this is my client. There's GUI-based clients, but I generally use everything on the command line. Most people do that are using Kubernetes. Developers, different folks use the kube command line. So to get this to work, I'm going to run kubectl, and I'll call a command called apply. And I'm going to do it from a file, and I'm going to say keen.yaml. And so that's going to take that YAML file that we just looked at, and it's going to deploy that to my cluster. And my cluster, if I do some commands against this, I can get some information about it. So if I do kubectl get, I can get something. So kubectl get, and then I'm going to say get nodes. And this is going to describe the nodes on my cluster. This is a single node. This is for demos. A production cluster would have 3 or more nodes, but this is a demo cluster, so it's only got a single node on it, which is fine. If I wanted to say get services, I can get a list of the services that I currently have running here, and this will show me the service that I just created when I created my application here when I did an apply. This Kubernetes service right here is the default service that is exposing things inside of my particular cluster here. But my application is exposed as a load balancer here, and notice it has a cluster IP associated with it, but it also has this external IP. This is a public IP address, so I should be able to use that to get my actual browser. I can plug that into a browser in just a second, which I'll do. If I want to see my deployments, I can do that. And I can get my deployment that I have, and then I also can get a list of all the pods I have running. So if I get pods, I currently only have one running right now. And so that's how I get information about what's running. If I want to do a describe, this will give me more detail-oriented information. So I can get describe deployment, and then I'm going to go keen like this, and this will tell me information about my deployment that I have running. And you can do the same thing for nodes. You can do the same thing for ingress, services, pods, whatever it is. Those are some of the basic commands that you can use kubectl for. Let's go over and then check out my little application I have here. So there is my my browser, and I'm going to do HTTP since that's on port 80, and I'm going to plug in this IP address, and then there's my little list of pages. I'm going to launch this little VNC right here. I'm going to type in my super PWD123 password here, and connect to this. And what this is doing is this is actually running a GUI-based application. This is running a DOS emulator, an old DOS emulator, in a container on Kubernetes on Azure, and I'm connected to it in a browser, streaming the results back to me. So if I go to cd install cd keen, and then I do install. This is an old DOS game I used to play as a kid, back when I was knee high to an ant. I used to play this on my mighty 286, and then it's a video game that allows you to side-scrolling action with Commander Keen. So if you've never played Commander Keen, highly recommended. It's what I played instead of things like Nintendo, and now I can play it inside of a container on Azure using Kubernetes and stream the results back to my browser. And this container image is available on Docker Hub. If you want to download it and play it, you can. This is shareware, so I'm not breaking the law by distributing it. Although I don't think you can buy the game anymore either. But in any case, that's this service exposed through a service through that particular IP. So let's go and look at one more thing before we take some questions at the end. So let's go over and look at my deck here. And let's look at this last concept called ingress. So we looked at a service already And we talked about pods, we talked about controllers, we talked about the pods already, we talked about controllers, replica sets, we talked about services for exposing those through a TCP connection. Now we can talk about exposing things through HTTP connections, because so much of the internet that we use is based on HTTP protocol. Kubernetes saw it fit to create this special kind of controller that handles HTTP-based traffic. And this HTTP-based traffic is done by a special kind of controller called an ingress controller. And an ingress controller allows you to basically define routes based on URL-based routing that come into your cluster. And so what you can do with that then is, using an ingress controller, is you can say, if, hey, everything that's route 2 goes to this service right here, then that service can then do the load balancing between the sets of pods. Anything with route 1 can go to this service here, and it can do the load balancing between those pods. So this will give you the ability to have very robust applications underneath a facade that basically is using routes to kind of mask the complexities of maybe even disparate applications. If you have a set of microservices, for instance, running underneath this, and so you want to expose one kind of functionality that's running in one set of pods using at one route, and another set of functionality on another set of pods using another routes. And this is how you can build APIs in Kubernetes without actually having to build a lot of complex infrastructure into your code to handle this. You can use ingress controllers to manage a lot of that for you. So let's go look at an example of this in code as well. I have a demo here already built for this, and I actually have a ton of demos. Like I said, I'm going to mention my YouTube channel that you can go out and check out, where I have tons of Kubernetes content related to this. This is an ingress controller definition right here. And so what this does is it basically takes everything I just talked about in the service exposure and takes it to and then exposes that using URL-based routing. So what I've got here is I've got a Kubernetes cluster add-on, and this one is, I need to expose this one as a gateway controller like this one instead of using Nginx. This right here is the one for Azure for dev tests that I have turned on currently for my cluster. And I've got some other things turned on right here. That's not really the important part. It is when you get down in the weeds, but I want you to mainly focus in on what I have here. And that is the routes I have defined here. I've got a base route, and it's going to a service on port 80. I've got another route here going to another service on port 80. I've got another route here going to another service on port 80. And then I've got Commander Keen again exposed right here on port 80. So I can go in, once I deploy this, I should be able to go into my browser, put in the IP /app1 and get app1, /app2 get app2, and do /keen and get Commander Keen as well. And so you can, and just to kind of look at what these are exposing, there's a service very similar to what I looked at. Notice the difference of this one, though. Instead of using a load balancer, I'm using a cluster IP instead. And so this is going to be internal to the cluster for this particular deployment. And there's the deployment. And I've got a couple other deployments down below, but you kind of get the picture that this is the manifest file for this particular application. So let's go ahead and deploy this guy. And let's go ahead and deploy this using kubectl. And let's see what happens when I do this. So let me get to that folder and to here. And I've got a couple other ones for app gateway I've got deployed here, but I'm going to deploy this one. I'm not using, you can use application gateway in Azure as an ingress controller. That's one of the options you can do. So I'm going to do another apply here, and I'm going to do from a file, and I'm going to use the ingress controller that we just looked at, ingress service deployment.yaml. And I'm going to deploy that, and that's going to create type cluster IP. You know what? I need to go remove the other one that I have, because I already have, I think, something like this already. So let's go back to demo 1 here, and I'm going to do kube. Let's do a kubectl delete -f, and I'm going to do the keen deployment that I already have, and that's going to remove that deployment and that other service that I already running that was conflicting with what I was doing here already. So let's go back and redeploy demo 2 here. And let's try that again. And I'm still getting a type cluster IP is invalid. Oh, it's probably because it hasn't changed it yet. So but the rest of this did deploy correctly. So let's try that one more time. It's still not going to let me do it. One more time. Node port, invalid node port. Not going to let me do it. So let's. I have that exposed as a cluster IP. Anyway, I think it's because I had that. Okay, there it goes. Finally, I wasn't patient enough for that other one to delete. So let's do kubectl, and let's do a get ingress this time. And this is going to show me the ingress that I have. I could do get services like I did before, and get pods. You can see I have a lot more pods now running. I can get ingress. I can get services. I get my list of services. Notice I have 3 services now. They're all cluster IPs, or 4 services rather. 3 of them are mine. One of them is the Kubernetes system service. I can get deployments if I want to do that. Get deployments here, and notice I have 3 deployments here. And my deployments now have 3. I have a deployment with 3 replicas in it, so I should be able to see those different instances of those running. So let's go over to the browser and let's pull up my ingress and see what I'm looking at here. So this isn't working anymore, so let's just repurpose this tab for this new IP, and let's do it for app 1. And this is my first app, and see, I'm refreshing it, and what that's doing under the hood is it's hitting a different backend each time because it's load balanced based on that service I was going to. Remember, I have 3 replicas running, and this name corresponds to the actual pod that this is running. So this is hitting a load balanced application through an ingress controller through a service. Same thing with app 2. So that new route right here goes to node app 2, and I'm just hitting refresh on the browser here to show you that I'm hitting a different pod every time I do a different request. And if I do something at the root here, I'm going to app 1 now because I had 2 different routes defined for app 1, and both of them are going to the same backend service. And then, of course, I can go to Commander Keen as well, and this is going to pull up the Keen pod that I had earlier, and I need to do /keen because that tried to route to the root here like that, and that looks fine. And if I do pwd123 here, I can log into this one again, and then this is the Commander Key. And you've seen this up and running already. So this is actually using WebSockets through an ingress controller through a backend service into a set of pods. So you can do things like WebSockets even through these ingress controllers, so you can get things like streaming results back to your browser and other cool things like that. So there's a lot of cool things that you can do with ingress. HTTP, you can do end-to-end encryption, you can do SSL offloading, and that kind of stuff as well. So that is the conclusion of what I wanted to talk about for the content for tonight. We're right up against, we've actually gone a little bit over. A couple of things just to wrap up. You follow me on Twitter. I'd love if you go out there and just, follow me on Twitter. I post a lot about Kubernetes, Docker related, Azure related stuff at the One Mule on that. And also, if you want more in-depth content related to Kubernetes, check out my Wintellect now. Check out my YouTube channel there. I have, like I said, I've got probably about 30 videos on container technology out there alone. So, and about 20 of those are Kubernetes. So a lot of deep dives into various aspects of Azure Kubernetes Services in particular. So definitely check that out if you want to subscribe and like my channel too. That way, I get more subs. It makes me feel better and all that kind of stuff. So I guess we can have the question. I know we're a little over, but I'd be glad to take some questions if we have some time for that, if you guys are open to that. So fire away. I'll be glad to field anything you might be able to throw at me.
I'll go first.
Okay.
So, what do you see, Blaze, in terms of companies? Obviously, if I would assume if they're using Kubernetes on-prem as they move to the cloud, that's a natural transition. But for those companies, let's say, that are adopting the cloud that had not used containers before, what is the primary motivation? Is it cost optimization of the cloud infrastructure? Is it a move away from legacy development to maybe more of a microservices architecture? What do you see driving adoption of
It's
containers?
it's very multifaceted. In my experience, the one of the main drivers is obviously modernization. App modernization seems to be a big reason for folks wanting to use Kubernetes. Containerization is a good way to do that. It gives you the ability to bring your own stack with you, and so if you have like a Java app and you're trying to modernize that, bring your own stack with you. So you bring the Java runtime with the container and you deploy that on Kubernetes. And Kubernetes is just the way to do that on the cloud. But a lot of folks want to be able to use legacy apps as well, which is sometimes kind of a case for Kubernetes. So it doesn't run well in PaaS, but they don't want to run VMs either. So they'll package it in a Kubernetes. They'll package it in a container and deliver it by way of Kubernetes as well. And it also, I don't know that it's really going to get you a lot of cost optimizations, but it does give you a lot of flexibility, manageability, and insight into your infrastructure and automation as well. So that's another real driver for it. Rather than having to maintain a whole bunch of VMs to run an application, maintaining a cluster is not a simple task, but it's usually simpler than running a bunch of VMs that are disparate and trying to get those all talking to one another and dealing with all the security requirements. Kubernetes kind of levels that and then brings it all into a unified platform. And then you just kind of focus in on making things run on Kubernetes in that more universe and that unified platform. So that's kind of a lot of the drivers for it. And app modernization, legacy apps, and then consistency. I guess is what I'd call that for kind of leveling that playing field for things across infrastructure.
Okay.
Any questions?
I think Max raised his hand.
Sure.
Max, do you have a
Unmute
question?
and ask.
Yes. So we have application currently running on Service Fabric.
Okay.
And with some recent development, it looks like the Kubernetes is the future. And so my question is actually, how to better transition from stateful Service Fabric application to Kubernetes?
Hey, is it using the Service Fabric deployment model?
It is.
Or are you using containers on Service Fabric?
No, it's Service Fabric deployment model, and I understand that will require a little bit of rewrite.
Yeah, you're going to do some refactoring there.
But it's not that. I don't expect that to be too much. But one of the things that we currently do is we processing data from Event Hub.
Yeah.
And because we process data from Event Hub, it has to be stateful because we need to maintain the number of readers. And so specifically for the task of processing data from Event Hub and Kubernetes, I tried to find some materials, but I didn't find many.
Well, being that it's Event Hub, you would have to use the SDKs inside of your application. So you would basically have to write a .NET app to kind of and take advantage of the SDKs for it. There's no native integration for Kubernetes for Event Hub, so you would have to basically create like a .NET daemon and then deploy that as a Kubernetes service. Another way that you might want to approach that would be maybe to use something like a function app, and then
I tried that, but specifically for Kubernetes because there is some cost benefits using it on Kubernetes, but specifically faithfulness.
So what I was getting with the function app is like with that you can containerize function apps. And you don't have to use those in app services. You can run those in containers as well, and that's got like native triggers for event hubs and things like that. But if you're just going to use event hubs and you want to roll that yourselves, you're going to have to build like a daemon and use the SDKs and to maintain that kind of state that you're talking about. Now, to get statefulness inside of Kubernetes, you would need to deploy something like a stateful set that you wouldn't want to use deployments for that, because deployments assume that you're not really using something that's stateful, or if you're maintaining your state outside of your actual applications, like using Redis, for instance, you could use a deployment for that. But if you're going to be maintaining it in the actual app that you're running, then you would need to use something like a stateful set or something like that in order to get that kind of state without killing your pod or moving that pod to another thing. It's just that's just one of the caveats that you'd have to handle with that. But if you wanted to go like getting it more stateless, you would probably want to get the state out of your application and maintain that with something like Redis or some other kind of state management system. And as a service on Azure, you can use Redis as a service, or you can maintain that inside of Kubernetes, and then move the state out of the actual pod and move that. So it's just it loads the state.
Event Hub where I have to maintain the number of readers and one reader per partition of Event Hub.
You're right. So you would want to use stateful sets for that and write a daemon inside of .NET to kind of manage that with the SDKs. There's not a native way to do that in Kubernetes.
Okay.
Hey, Josh, did you have a take on that you wanted to share?
Yeah, there's something a little bit newish if you don't mind being a little bleeding edge, something called Dapper, which is this distributed application.
Yeah, I looked into that as well a little bit. Yes.
Yeah, Dapper,
Yeah, that has some statefulness. It was actually it's being written by the Service Fabric team.
I would steer clear of that for a little while. That's just my opinion, but okay.
I think it's a little bit different, serving a little bit different task. The Dapper, from what I understand, it's really a microservice thing, and here is a little bit different task.
It's kind of Microsoft's attempt at a service mesh, and I would go with more. I don't. I just there's no Kubernetes native way to do that. You're just but you could try some of the third party attempts at it, but I don't know of any Kubernetes way of doing that unless you wanted to just use the SDKs and then create a daemon, and then you do go that route.
Mm-hmm. Okay, thank you.
Any other questions?
I have a couple of questions. So do we have inbuilt dashboard that is available to look into like what pods we have from Azure?
So in Kubernetes, if you go into the dashboards, it's a preview feature as of right now. In the Azure portal, you can see your services that are running. Let me see if I have that up in here. That's not it. That's something else. Where's my tab here? Let's go to portal. It's just portal.azure. Have Facebook and other things up. And let's go into, I think I might be able to see it. So like here under workloads and services and ingress, it shows me my pods that are running. And if I go over here to services and ingress, I can see, ports and the IPs that I have exposed. So it's right in the portal now. It's still a preview feature. So this doesn't work on private clusters, but it does work on public clusters. And you can also use like tools like Rancher if you want to do that, and you can use tools, there's also the Kubernetes dashboard that I can't remember the command, but there's a way to run kubectl to get a proxy that will launch a browser that will give you a connection into your Kubernetes dashboard as well. But the easiest way in Azure is just to go to the portal and just pick this, and it shows you your ingress and services and the ports are mapping the IPs, etc. Right there in the portal.
Okay, so can we control like from the portal itself, like if we want to delete any deployment services, can we do that, or is it
not as of right now that I'm aware of?
Okay.
Now you can, it does show the YAML. It does. Okay, it does allow you to do save and review. If I just change this, okay, I haven't played with this much yet. Discard. Yeah. Okay. So you could do that. It does give you the ability to do YAML edits, which would basically give you the ability to change things in the portal as well. This is a brand new feature. So again, the last 2 weeks this is kind of launched. This
one, thank you.
So again, I haven't played with it a lot, but it does give you exposure to what you have, and you can edit the YAML. You could probably delete it right here, or you could create different kinds of things like that. So this is a brand new thing in Azure. Just something to think about if you want to use this. But again, if you don't want to use this tool, of course, Rancher or the Kubernetes dashboard are another one you can use.
Okay. Yeah, the other thing is regarding the RBAC. Previously, you spoke about it.
Yeah.
So do we have to create groups and accounts in Kubernetes inbuilt to have them tied to Azure AD groups?
You would have to create an RBAC role in Azure. In Kubernetes. Like you create there's a way to Google the AKS RBAC Azure AD, and what you end up doing is you end up creating what they call a role inside of Kubernetes, and then that gets bound to an Azure AD group, and then you can assign people into that group, or you can assign it to individuals, but you generally assign it to a group in Azure AD, and then you assign people into that group in Azure AD, and then whenever that user logs in, they will be granted access to different resources depending on what you put into that role inside of your Kubernetes cluster. So you have to create that role in Kubernetes first and bind it to a group in Azure AD, then add the users into the group. That's how that works. But you don't have to use Azure AD, you can use other IDPs as well. Kubernetes doesn't have a built-in IDP, and so you have to bring one, and it's got a lot of plugins for it. Azure AD is just one of them, but it's the first-party offering in Kubernetes for it. It's not available in the cluster in the portal yet to sign it up, but it's GA, so it should show up here in the portal and soon, so you can create it when you create your cluster in the portal. Otherwise, you have to do it through PowerShell, Azure CLI, or ARM templates.
Okay. Yeah. And the other question is like currently I saw that the current Kubernetes cluster is running on 1.16. So for example, if I have like a previous versions and if I want to upgrade to newer versions, so usually what is the process if we have like multiple node pools?
You would go into like the individual node pools are going to be, you can come in here and you would upgrade that individual node pool right here. Since I only have one node pool, it's like you could upgrade individual node pools. Like come in here you can do it in the portal. You can do it through the Azure CLI or through ARM templates or CL or PowerShell. But you can come into the portal and just upgrade, go up a version. You can't go back though, so you couldn't downgrade, but you can definitely upgrade right here on different agent pools right here in the portal. So
okay, once we upgrade the node pool, and then we have to upgrade the Kubernetes cluster service.
You would upgrade like this. This would upgrade your Kubernetes version for everything right here. And so this kind of upgrades everything. This upgrades like node pools. This upgrades individual agent node pools right here. So like I can upgrade individual node pools or I can upgrade everything right here. Sorry, under upgrade. And because node pools are optional, so you don't have to turn these on. But that's how you would do that. Microsoft is trying to build more management tools into the portal rather than having to do it all manually through like Kubectl or Rancher or third-party tools. So that's kind of the gist there.
Okay. Yeah, I have like a couple of other questions, but I will let others to ask the questions. And if they don't have, I'm happy to.
All right. Any other questions?
Out of curiosity, this is Josh. Do you have any opinions on Microsoft's new Open Service Fabric? Or I'm sorry, come on, I'm thinking Service Fabric here. Open Mesh.
Open Mesh, yeah. I was thinking, yeah.
Sorry. Open Service Fabric is something totally different. Open Mesh.
Yeah, Open Mesh. I honestly don't because I haven't really delved with it. At the end of the day, I think they're $1 short, a day late on that. Because Istio is just kind of that's kind of the one you would want to use. Most people, like if they're thinking service mesh, they're thinking Istio, just because Istio, for those who aren't familiar with the idea, the idea of a service mesh gives you an abstraction on top of Kubernetes for managing complex microservice architecture. I've got a whole video out there on the YouTube channel if you want to check that out on Istio and what a service mesh is. But I was like, I'm just, it's kind of like a day late and $1 short in maybe it'll take off. I doubt it will, but to me, it's, when you got something like Istio already, why would you go to something else? That's kind of my thinking. There's other ones out there. There's one called Linkerd, and there's another one that's based on console that are Linkerd's a little bit less heavy than Istio, and it's a little bit more basic. Maybe used for smaller clusters, but and consoles is it's not that great. But Istio is just the one to use. I mean, I really wouldn't go any other way, honestly. So maybe you have an opinion about that. I don't know.
No, and quite frankly, I'm just dangerous with Kubernetes. I fall on the serverless side.
Yeah,
so
you're working with app services. I do quite a bit with that too, but
I'm just kind of curious because it's all I've heard horror stories around Service Fabric. The monitoring aspects of it, the visibility aspects of it, the management aspects of it.
Service Fabric is coming in the redheaded stepchild in Microsoft now, just because it was when Kubernetes became so popular. Service Fabric just kind of seemed like this kind of like redheaded stepchild in Microsoft now, because Microsoft's throwing all this resources at AKS, and then their Service Fabric guys are like, "Hey, we're still here. Come to us." And it's not because Service Fabric is bad. It's just kind of becoming.
It got overshadowed.
Relevant. Yeah, it's just not. It's like, why would you use Service Fabric when you can use Kubernetes? I mean, it's just.
I agree with you. It's ironically, Service Fabric runs a lot of stuff behind the scenes in Azure, so it's not going.
It's kind of the funny thing about it is it's like most of Azure is built on Service Fabric. It's just for the general consumption, general purpose consumption. It's just not what I would use for containers or microservices.
No, fair enough. And like I said, your answer, I think, on the open, and I keep on throwing back and forth Service Fabric and Service Mesh. Sorry, but no, I think your answer on Service Mesh was spot on. I think it's that seems to be some of the consensus I hear too.
Yeah, I'm kind of like I'm open to it, but I'm at the same time I'm like I just don't have a lot of it just doesn't seem to be any reason right now to adopt it. Microsoft's not making us adopt it, so they fully support Istio on Kubernetes, so use it. Any other questions?
Okay, yeah, I will go with a couple of other questions. So you were speaking about Nginx, ingress controller, where we can control multiple applications through that. Yeah. So is it going to replace the application gateway, or how can we integrate application gateway with Kubernetes?
So, okay, you remember the ingress controller I showed you? You would basically replace this line right here with a line that is for you'd say the class of ingress controller, you would say use the application gateway ingress controller. The rest of this would pretty much be like it is. You could use the same syntax for it. There's some annotations you want to add into this that you would need to tweak a little bit, specific for application gateway. But otherwise, the rules, the specs, all of this would work the same way. And what you can do with that then is you can use application gateway as the application gateway ingress controller to act as the front end for your application. You can turn the WAF there. You can do all your SSL terminations there and let that be managed by application gateway. You can use Nginx. You can use Trafic. You can use any number of, you can use HA proxy. There's any number of ingress controllers you can use. On Kubernetes, probably Istio. I've talked a lot about Istio. Istio's got its own ingress controller. Nginx is probably just kind of the low-hanging fruit because it's so ubiquitous to that. This one actually right here, this add-on HTTP application gateway routing thing is using Nginx under the hood. But this is one that you can also install Nginx first party through Package Manager Helm, which I didn't even mention, and get that up and running as well. But it's a really nice as well. So I don't really have a strong opinion on which one to use. I just say use whichever one works for you, whichever one you're comfortable with. They kind of all work the same to me because you're going to be configuring them through this service, through this spec anyway. And so you're not going to really see a lot of the inner workings of those different kinds of ingress controllers. So pick one and stick with it. That's kind of what I would say. So
okay, so if the Nginx controller is going to have like connection with the external load balancer, like when we want to
So what it does is whenever you create this, it's going to connect. Like anytime you have an ingress controller on Azure, or Azure Kubernetes Services, it's going to expose that through a load balancer, a network load balancer on Azure. And so that load balancer will you can expose it as internal load balancer or external load balancer, and it will get an IP address, and then all your traffic will hit that. You don't really have to worry about creating that. It will do it automatically for you. And so you just say, hey, create me an Nginx controller. It will create the load balancer. It give you the IP for it and everything. And all you have to do is just define it here in your manifest file, and all the automation that Azure does for you will create that load balancer, configure it for you, and all the ports and everything for it to work with your ingress controller.
Okay, so is it going to create like every time like we run the Nginx controller? Say for example, if we have like multiple applications running, so each time if we run the Nginx, is it going to create external load balancer each time?
Well, it's going to use a load balancer. It's going to have two load balancers, going to internal and external. It's going to use one of those two under the hood. Inside of the portal, you can actually see the resources that it creates. So if I was to come over here and look at the portal and look at, I come back over here to my home, it's going to create a resource group that gets exposed. And what you'll see inside that resource group, this is mine right here. You're going to see all the resources that it creates for you. don't touch these. These are managed resources, but it's going to create a load balancer right here. And if I was to create an internal load balancer, you would see Kubernetes-internal, and you would see a private IP assigned to that. So it's creating a load balancer. It's only going to use one for external, one for internal, but it will allocate as many public IPs as it needs and as many internal IPs as it needs. But it only needs one load balancer to do that.
Got it. Thank you. And one last question. So are there any limit on number of pods that we can like deploy on a particular node?
Number of pods? I should know that number. There is a limit. I think it's like 50 or 100, and you can change it. So it's not, I can't remember the number. I should know it, and I can't remember what it is, but it's some arbitrarily large number, and you can change it if you want to, but I don't, but yeah, there is a limit. And it's something that if you create large nodes, like have a lot of cores, a lot of RAM, you can change that, tweak that number to say, hey, I want a bunch of more pods in that. But if it's a bunch of small nodes, you might want to turn that number down. I can't remember what the number, but also what Kubernetes will do is it'll try to maintain a maximum number of pods, or based on the resources available too. So if you say reserve a gig of RAM for this pod, then you only have 4 gigs of RAM and you create 4 instances of that pod, it won't allow any more pods in on that node because it's out of RAM. It won't allow you to deploy more stuff than it's capable of handling. And so Kubernetes is going to do that by default if you define those resource limitations inside your manifest. I didn't do that inside of mine. I don't have any resource limitations on any of this. So it's just going to keep cramming in pods until it runs out of CPU, or runs out of compute, runs out of network, or runs out of whatever, because I don't have any of that. I did that for simplicity, but for production oriented workload, you'd want to say, hey, I need at least a 50% reservation of the CPU available, or I need at least 256 megs of RAM, or a gig of RAM, or 2 gigs of RAM, whatever it might be for your application.
Okay. Yeah, I tested with AWS, but not test with Azure one, because AWS one, it depends on the number of interfaces, the network interfaces that the node has. So is there kind of such thing for Azure also?
I don't think so, because Azure is not going to, it's just going to use the same NIC on the same VNet, and it's just going to keep adding IPs to it. It's not going to try to create a new NIC for every instance of your application. It's just basically, if you need multiple IPs, it'll allocate multiple IPs to the same NIC and attach that to your VNet, and then that's how it's going to connect to it. I've never seen any kind of, like, there's some arbitrary large number of possible nodes that you can put on a Kubernetes cluster, and the arbitrary number of possible of pods that could handle. So, like, I think you can have up to 100 nodes, and if you use the maximum sums of VMs, you could end up deploying like 40 or 50,000 type pods, which would be a fairly large application, or a lot of different applications. But I would actually go with multiple clusters before I did that. But yeah, so it's not, I don't think there's any restrictions like that on AKS that I know of, that I can think of.
Got it. Yeah. And the other question is regarding the selector. You mentioned that we need to have the selector in the YAML files. So what happens if we don't have the selector? Like, I'm a bit confused on that concept.
So, like, if you don't have a selector, it doesn't know where to send it. So, like, for this one, it's using service name to match the service name to match this. That's my selector for the ingress, to match to the service name right here. And that's how it's mapping this onto this. If you don't have those selectors defined, it cannot connect those together, because Kubernetes is not defining things based on explicit IP addresses or explicit names. It's basing it on the way that you define labels and names inside of the metadata that's associated with your services. And then you need those selectors depending on what you're deploying. Like, again, an ingress uses service name to map onto a service, and then a service uses a selector to map onto a deployment. And then a deployment, of course, uses a deployment template to deploy to determine the pods. But that's how you map these things together, is using that selector syntax. And and also in Kubernetes, you can use the selectors for querying against your Kubernetes cluster. Say if you had a label that was like, I don't know, app, let's say department or something like that. You could say, give me all the services for department X, Y, or Z, and you could use the labels as selectors for your pods. So you need to have selectors to not only link resources together, but it gives you management manageability of your cluster as well. And you can put RBAC around those. You can do a lot of things with those kind of selector technology, those selectors. That's why you kind of have to have that in your Kubernetes cluster, because there's so much of the functionality in Kubernetes is kind of baked around those selectors, as well as using labels and other metadata associated with it.
Got it. Yeah, thank you so much, Blaise. Yeah,
Okay.
This session was really helpful.
Any other questions, comments, concerns, confessions? We can skip the last one, but if that's all,
leave that.
if that's all, please do check out the YouTube channel. There tons of content related to Kubernetes, and also my Twitter feed. I constantly post a bunch of junk out there about Kubernetes and other random things that that come through my head, but it's nothing political, so I'm not going to tell you who to vote for or anything like that. Nothing like that. It's tech and pretty pretty benign, usually humorous type stuff. But definitely check out my YouTube channel, because that's where you're going to find lots of content related to Kubernetes, because it's something I love to do. So there you go.
Thanks, Blaise.
That
That was pretty necessary.
Very well
Very
done.
good. Very nice.
That was 2 in a day as well. Just got better with age, better with time. I've recorded all of this, guys, as well. So if you want to watch it back, I'll make sure to release it on our LinkedIn.
Yeah, I'm just going to post this. I actually recorded it as well. So I'll post it on my YouTube channels. If you want to go there, just go to youtube.com/Wintellect and check it out. I'll probably have it up in the next day or so.
I think you deserve a subscribe after that.
Yeah.
So
Yes, absolutely.
I've actually got probably 2 or 3 versions of this talk out there already, as well, because there's a whole list of webinars, and a lot of them I've done, but yeah, this one I'll put up there as well, and so you can review it. So yeah, definitely check it out.
Great. Thanks, Blaise.
All right, we'll do it.
Amazing.
All
Thanks
right.
very much.
All right, talk to you guys later.
All right.
Cheers,
Thanks
Blaise.
everybody for attending. Thanks IO Associates, and thanks for all the new members. Spread the word, and we hope to see you in the next session.
Cheers, guys. Enjoy your evenings.
Thanks.
Thanks all.
Thank
Take care.
you.